Welcome back, students. We're going to be going through how to get arc length, but in this time talking about how to use it with radians. And if you don't know what a radian is, I do have videos that explain what a radian is in a little bit more detail than what I'm going to currently go over. But the gist of it is, 1 radian is an angle measure that specifically opens up to an arc length of 1 radius. So when you have an arc length that's exactly 1 radius, that angle measure is called a radian. And around the circle, there are 2 pi of them. So I'll show you kind of why. So if I wrap this radius here, if I do another one, that's 2. If I do a third one, that's about right here. Let me do half the circle here. And if I do a fourth one, a fifth one, and a sixth one, there's just a little bit more, and it's about 0.28 radians. Now, what we typically think of in a circle is not the full circle, but 1/2 of the circle. So half of that circle, if I cut that in half, is 180 degrees, which is equivalent to 1 pi radians, 1 pi radians, which is 3.14. So we have a more simplified formula we can use now to get that arc length. And we're going to call that arc length S, which is the same distance as what you previously learned as L, but we use S in this formula not to confuse the 2 lengths, and we can make sure we can use the appropriate formula. So what you do is you take the radius and you multiply it by the angle, but the angle has to be in radians. Now, a quick way to convert from a degree to a radians is you take your degree measure. So let's say I wanted to do 50 degrees. So I would say 50 degrees, and I would multiply it by pi divided by 180. And that'll get you your measure in radians. So if I were to take 50 degrees and times that by pi and divide by 180, that's going to be approximately 0.87 radians. And if I converted that to 360 degrees, that is fully 1 rotation around the circle, which is 6.28 radians. 180, well, the 180s would cancel out, and you would just be left with 3.14, which is pi. So you can take any degree measure, multiply by pi, divide by 180. You can get that in the form of a radian. You can also work the other way. So if I was given a radian and I wanted to convert it to degrees, I would take my radian measure and I would multiply it by 180 over pi. So I would just flip that fraction. I'll show you on the calculator how that works. So suppose I give you in a circle 5.3 radians. And I want to know how many degrees is that approximately. I would multiply it by 180 divided by pi. Basically flip that fraction. And you would get about 303.66 degrees. So that's not quite fully around a circle, but if you think about, well, if I did 6.28, that's right around 360, and that's because 6.28 is 2 pi, so that's 1 full measure around the circle. If I did about 3.14, that would be about 180 degrees, so that's halfway around the circle. So just basic conversions back and forth between radians and degrees. But right now I'm going to focus on using the formula that involves arc length and radians to help solve for problems. Now, on this handout, you're going to see a formula that says S equals R times theta. S is going to represent the length of the arc. So that's usually going to be measured in inches, centimeters, whatever you have. The central angle in this case is still that theta symbol, but in this problem, it means radians. So when I see that symbol there, that's just straight multiplication times the radius, which is R, and you'll get that arc length. It's a very basic formula. In this handout, I've already provided videos going over the first 2 problems here. So I'm going to focus on slides. This is on a Desmos activity, 6, 7, 8, and 9. You also have this on this handout. And we're going to go over these 4 examples, and I'll show you how to use the formula. So let me clear this off. Example slide 6. A circle has a radius of 5 units. We want to know what the radian measure of the central angle that intercepts an arc with a length of 15 units. It's kind of formatted awkwardly, so let me split that up. So we have an arc with a length of 15 units. That length, in this problem, we're going to call S. We don't know the units, so I'm just going to say 15. And we know the radius is equal to 5. So the question wants to know, find the radian measure. Now, radian is a way to measure an angle. So that's the theta symbol. And in this formula, S equals R times theta. I usually just write R theta. Then you have the two things you need. So since we know that the radius and the length are given, we can plug in 15 for the length, and we can plug in 5 for the radius, and we can solve that for theta. Now, at the end of the day, this is just multiplication. So to solve for theta, we're going to divide both sides by 5. 15 divided by 5 is going to be 3. So that's going to be 3 radians. And that's your answer. So when I'm writing my answer, I say theta is equal to 3 radians. And radians don't have a unit, okay? It's like degrees is your symbol. With radians, you just say 3 radians. If you want to abbreviate that, you could say 3 rad. But that is the unit for radians. That's how you measure that angle. Let's look at number 7. A circle has a radius of 7 inches. What is the length of an arc? Length is S, intercepted by an angle with a radian measure of 8/5 pi. Well, radian measure is theta. We're actually given that, okay? Your theta is equal to 8/5 multiplied by pi. And we know that our radius is 7. So in this formula, S equals R times theta. We're trying to find S. We can plug in 7, and we can plug in 8/5 times pi. So this is already ready to be multiplied together. Go ahead and use your calculator and plug those in and see what you get for a length. All right, in my graphing calculator, I would just do 7. You could do parentheses 8/5 pi. Now, when you type it like this, the 8 divided by 5 does represent 8/5. If that kind of worries you how you type it, you can use your fraction menu. So this would be 7 multiplied by, and then I could go to alpha y equals and do n/d. And then just put the pi next to it. That number represents the length of the arc. And so since I'm given inches here, I'm going to keep the units in inches. So our length is going to be about, I'll do a little approximately equal to, it says nearest hundredth. So 35.185 can say 35.19 inches. So that's how long that arc is. Again, pretty basic formula. Again, just use S for the length so you don't confuse it with the other arc length formula that we have. See if you can try these last 2 problems. If you want to pause the video, unpause it, and you can check it with me. Okay, number 8. A circle has an arc length of 8/3 pi. Arc with a length of 8/3 pi, that's S. If the radius of the circle is 12 centimeters, what is the radian measure of the arc? They want to know the radian measure, so that's going to be your theta. We don't know that. So we'll plug it into the formula. S equals R theta. S is 8/3 pi, so I'll write 8/3 pi over here. We know that the R is 12, but we do not know the theta, and it says round to 2 decimal places. So I'm going to take that 8/3 pi and divide it by 12 to solve for theta. Let's be careful how we do that. I'm going to use parentheses around the 8/3 pi when I type it in my calculator, or you can compute it separately and then divide that number by 12. But I'm going to do that here so that way I can type it in the same way. So this is going to be parentheses 8 divided by 3. And again, just hit times pi. That'll put the pi to the right of it. And then close that up and hit divided by 12. And that degree measure, I'm sorry, not a degree, that radian measure is about 0.698. So it's a fairly small radian measure. And you might be wondering to yourself, that doesn't seem like that would be an appropriate number, but I want you to think about what the number 8/3 pi is. Let me draw a little picture for you so you can get a reference. All right, if I have a radius that's 12, so I'm going to say 12 here. And if I take 8/3 pi and actually compute that, I get about 8.377. Well, that's my length. Now, if this 12 here represents the radius, and my length's only like this much, 8.38, we'll just call it. Well, then that angle measure is going to be small. That's going to be less than a radian. Remember, if it were exactly 1 radian, that would be 12 along this length, but it's less than 12. So that radian is going to be a smaller number, and that's where the 0.698 comes from. So that radian measure is equal to 0.698, and it says around the 2 decimal places. So I'll just bump that up to 0.70. So it's going to be 0.70 radians. 0.7 is fine too. So about 7/10 of a radian in this problem. All right, the last question here. I'm going to go ahead and delete this, so write it down if you don't have it. Here we go for the last example. The question says, if the length of an arc is 10 inches, not if, the length of an arc is 10 inches, if the radian measure of the arc is 4/9 pi. So we actually know what that radian measure is. We'll call that theta. And since that's the radian, we're going to call the length S for the formula S equals R theta. And it wants to know what the radius is. So again, the radius is, well, we don't know. We'll find it out. So we'll plug in what we have. Our S is 10. Our radius is unknown. So we'll put R, and then we'll put 4/9 pi. And we want to know what the radius is. So once again, we're going to divide by all that stuff. And we'll just be careful when we calculate it. Use parentheses, make sure everything is inputted accurately. And we'll put 4/9 pi, both sides. We'll cancel it out, and our radius is going to be whatever this right here is. So let's key that in, and it says round to the nearest 100th of an inch. So 10 divided by, parentheses, 4/9 times pi. And so that radius is going to be about 7.16. And since our units are in inches, we'll leave that in inches. Hope this helps. Thanks for watching us. Have a good night.